Well, good afternoon, everyone. Thank you especially, of course, to Boris Mintz for this tremendous honor. I'm really delighted to be able to be here today to talk to you and to receive the prize. It's truly an honor. Большое спасибо. And of course, to the Board of Governors of BMI and to Professor Sennett and Ayelet Fishman, who were very helpful in bringing me here and organizing all of this. Before I start my talk, I have to observe that the focus of BMI is renewable energy and food security and conflict resolution. It doesn't say water. I would also note, of course, that water is connected to every one of those things. And one of the things I'm going to speak about today is the fact that water is connected to everything we care about. I also promised that my talk would be somewhat positive. I'm going to talk about the nature of the crisis we face around water resources, but I'm also going to talk about a positive future for water so that hopefully you will not leave here too depressed. Water is increasingly on everyone's mind, of course, given the wide range of challenges we face, our continued failure to provide safe water and sanitation for everyone on the planet, floods and droughts, contamination of water supply in cities and in rural areas, the growing evidence of human-caused climate change, violent conflicts associated with water resources, and much more. Much of the news about water is bad, and I'm going to describe these and other challenges associated with water. But I also believe that the future for water involves a transition to what I believe is a truly sustainable future. I'm an optimist at heart, and so I'm going to describe that transition. And I think we're in the midst of that transition right now. We live on a water planet. As the writer Arthur C. Clarke once observed, if we didn't happen to live on the dry parts, we would probably call the planet ocean rather than Earth. And of course, for humans, water is critical to everything we care about. It's critical to life. It's critical to the quality of life, our economies, our healthy ecosystems, all of the things that we care about. Most of the water on the planet, as we heard earlier this morning, is salt water. 97% of the world's water is in the oceans. That's the big blue dot, if all of it were a single sphere. And even the remaining 3%, the fresh water, is mostly inaccessible to us. It's locked up in the ice caps in Greenland and Antarctica. It's in deep groundwater. It's in remote parts of the planet. So only a tiny fraction of the world's water is the water that we use for growing food, for our industries, for human use. As we get older, both as individuals and as a society, we learn more. We absorb knowledge from people around us, from science, from experience, from our peers, from others. We face new challenges. We find new opportunities. Circumstances and conditions change. The world evolves, often with growing complexity, growing diversity, growing interconnections among issues. How often do we hear or think to ourselves that the world used to be a simpler place, that we wish nostalgically for the days gone by? Life was easier, we hear, or I long for the good old days, or, oh, we used to do things differently in the old days, or if only I had been born 100 years ago or 200 years ago, and so on. Some of this is wishful thinking, belief in a past golden age, at least for society and civilizations. And there have been very many different golden ages throughout civilizations' eras. But one characteristic of golden ages is, first of all, they don't last very long. And second of all, sometimes in hindsight, they turn out not to be all that golden after all. And in my talk today, I'm going to talk about that. I'm going to say that's really the case for fresh water. I think that despite the challenges and the problems we face around water, we're better off today than we used to be in many ways. That many of the trends are in the right direction. And in fact, I'm going to argue that our best days, our golden days, if you wish, are coming, that they're in the future. And I'm going to describe today what I call 3 ages of water, problems that we have to still overcome, and new approaches and tools that we're using and are going to have to use to address those challenges, both globally and locally. Specifically what I call the soft path for water. I'm also going to talk about ancient Mesopotamia and Sumerian myths and cholera, climate change and Mars and the moons of Saturn, the Syrian civil war, Kashmiri proverbs, Israeli water progress, and of course 19th century poetry, all of which are related to water. For most of the people living on Earth, the first age of water extended from ancient prehistoric times up until the end of the Middle Ages and the beginning of the Renaissance, perhaps the 14th, 15th, 16th centuries. And this first age of water consisted simply in the reliance on taking water from our rivers and throwing our wastes back into those rivers. That's what we did as ancient humans, and that's all we knew how to do. Our rivers and streams were the source of our water resources, and they were the repository for our wastes. And when the population of the planet was small and widely dispersed, that was okay. Life was pretty miserable anyway. Life was short and brutish. Water-related diseases and other diseases were rampant. There was malnutrition, there were plagues, there was complications of childbirth, and this was not a golden age. The first age began to end, however, when growing concentrations of people required a different way of thinking about water. It required more centralized services. Villages started to outgrow their local water supply. The transition from the first age to the second age of water really began in ancient Mesopotamia and in the Indus Valley in India. And it started really along the great rivers of the world, along the Tigris and the Euphrates River in ancient Mesopotamia, in what is now Turkey and Syria and Iraq, and along the Jordan River in what was Canaan and Lebanon and the early parts of the Middle East. In the Indus Valley, along the Ganges and the Brahmaputra. The earliest cities of the Romans and the Greeks, when they developed ways of transporting water to meet the needs of ancient civilizations, of growing cities, in Granada and elsewhere. But in some ways, the second age of water really began to flower in the 18th and 19th centuries. And this was a period of time when the cities of Europe and the Americas and elsewhere were reaching critical size. They were outgrowing and contaminating their water resources. The Black Death had decimated Europe, worsened by growing populations without safe water and adequate sanitation, and by a population that had very limited understanding of science or medicine. And the Renaissance included not just a blossoming of art and natural philosophy, but a rapid expansion of science and engineering. And an important part of this scientific revolution, the second age of water, was the development of the scientific method, with its emphasis on empirical evidence, the formulation and testing and modification of hypotheses. And early influential proponents of these ideas were Copernicus and Galileo and Francis Bacon, not without opposition from ideological corners, I might note, as experienced by Galileo with his experience with the Catholic Church. But the scientific method led to great advances in many different fields, accompanied by growing skills in engineering and construction and technology, for medicine, for astronomy, for biology, for physics, and for the environment, including, from my perspective, water resources. By the early 1800s, it was very clear in Europe that we were fouling our own nests. This is a map, an ancient map of the city of Cologne in Germany. Actually comes from the archives of Hebrew University in Jerusalem. And in 1828, after visiting the German city of Cologne, the poet Coleridge wrote the following: "The river Rhine," which feeds the city of Cologne, "the river Rhine, it is well known, doth wash the city of Cologne. But tell me, nymphs, what powers divine shall henceforth wash the river Rhine." This was a time when cities were dumping all of their wastes again into their local cities. Uncontrolled water pollution with human wastes had other consequences. By the middle part of the 19th century, by the middle of the 1800s, cholera and dysentery were rampant in cities in Asia and Europe and in the Americas. London closed Parliament in 1858 because the River Thames was so horrible and so smelly in the summer that they had to flee the city of London for the summer. In 1858, there was something called the Great Stink in London. This is a cartoon in 1858 from the magazine Punch. It says, "Father Thames introduces his offspring to the fair city of London." This is diphtheria and scrofula and cholera, some of the diseases that were contaminating the city and causing enormous illness that turned out to be water-related diseases. And Benjamin Disraeli, who would ultimately become Prime Minister of England, called the River Thames a Stygian pool reeking with ineffable and intolerable horrors. And for those of you who don't remember, the River Styx was the river that you had to cross to get into hell. And that was his perception of the River Thames. And the Illustrated London News, the major newspaper of the time, in 1858 said, quote, "We can colonize, we the British Empire, we can colonize the remotest ends of the earth, we can conquer India," my apologies, this is the British Empire in 1858, "we can pay interest on the most enormous debt ever contracted, we can spread our name, our fame, our fructifying wealth to every part of the world, but we cannot clean the River Thames." And that was the challenge of the time. Cholera outbreaks by the mid-1900s spread around the world, as I mentioned, from Asia to Europe to the New World. Ships brought cholera to New Orleans and then up the Mississippi River and then out the Oregon Trail to the west coast of the new Americas. Philadelphia, Chicago, New York, London, Paris, Moscow all experienced enormous outbreaks of cholera in this era, killing thousands of people at a time. But this was also a time when scientists were beginning to discover what caused these water-related diseases. Cholera in the 1850s, they didn't know whether it was an airborne disease or a waterborne disease, and they discovered in the 1850s that it was a water-related disease. Scientists were making the connection between these diseases and contaminated water and the byproducts of a rapidly growing industrial revolution. And as these connections were made, civilization experienced these advances, remarkable advances in science and technology and engineering applied to water. We saw the first machines developed to provide water supply. We saw the first chemical, physical, and biological treatment of wastewater. We saw the first dams of gigantic scale to hold back floods, to provide water during droughts, to produce hydroelectricity. We developed and deployed technology to move water, not the hundreds of miles that the Romans and the Greeks were able to move water, but thousands of miles through mountains, over mountains from one river basin to another, and to produce electricity from hydropower. We saw the first large-scale irrigation systems to permit farmers to grow large amounts of food in places and at times when we were never able to grow food. All of us grew up in this second era of water. All of us have benefited from those advances in the second era of water, and we're still living in the second era of water. Cholera, typhoid, dysentery have been eliminated in the richer countries of the world. We're feeding more than 7 billion people because of the Green Revolution, which was as much a revolution in irrigation technology as it was a revolution in crop types and agricultural fertilizer and other advances. Sophisticated water systems protect us from floods and droughts, mostly, and they deliver water to us and they take away our wastewater. We are literally finding water on other planets. This is a photograph from the Mars orbiter of what appears to be liquid water on the surface of Mars at some times. And this is water vapor coming from the Saturn moon Enceladus. And we're finding water basically everywhere in the universe that we look. In fact, some of my colleagues in California wish we would spend more effort there trying to find water here on Earth. And the truth is, we take almost all of this for granted, those of us in the richer, more developed countries of the world. But as we entered the 21st century, things are changing once again. Water is again taking center stage as the most important resource for us. Why? Because despite the advances of the second age of water, despite the technology improvements, the improvements in economics, the improvements in management, we still have a water crisis. Despite spending hundreds of billions of dollars developing water systems, despite the money spent by utilities or towns or countries or the international community, we still have a water crisis. Not only have we not solved all of our traditional water problems, but we're also facing some new challenges. When I say there's a water crisis, what do I mean? What does it look like? So the first piece of this is the failure, despite all of these advances, to meet basic human needs for water for everyone on the planet. Populations are growing, and it's the 21st century, and yet there are almost 1 billion people worldwide that don't have access to safe drinking water. There are over 2 billion people worldwide that don't have access to, again, something most of us take for granted, that is safe, reliable sanitation. And because of the failure to meet basic human needs for water and sanitation, we still have water-related diseases, hundreds of millions of cases a year of preventable water-related diseases, and 2 to 5 million deaths, mostly of small children, from cholera, dysentery, typhoid, and other diseases. We passed the 2015 target date for the UN Millennium Development Goals, and we've now set 2030 for the Sustainable Development Goals, one of which is to provide safe water and sanitation for everyone on the planet by 2030. And it's going to be a very difficult challenge to meet that objective. Second, we have water quality challenges that continue to face us, both human and industrial wastes. We have industrial water quality challenges depending on the industries involved. The failure to provide adequate sanitation leads to human wastes contaminating our waterways and our ecosystems. And we have not addressed water quality challenges around the world, even in places where we thought we've addressed them. This is a photograph of the Cuyahoga River in Ohio in the United States in 1952. The Cuyahoga River feeds into Lake Erie. Over a series of years in the 1940s and the 1950s and the 1960s, the Cuyahoga River would catch fire because of industrial wastes. And in 1969, the Cuyahoga River caught fire, but this time it was on national television, and it was at a time in the United States when there was growing awareness about environmental challenges. And that time, Time magazine described the Cuyahoga River as, quote, the river that oozes rather than flows, and in which a person does not drown, but decays. And this event, together with the growing awareness of environmental challenges, helped trigger an environmental revolution in the United States. It led to the Clean Water Act. It led to the Clean Air Act, two national pieces of legislation that have helped improve the environment in the United States. And yet, in 2014 in the United States, we saw the James River in Virginia catch fire when an oil train accident spilled oil into our rivers. And also in 2014, we saw a tremendous algal bloom in Lake Erie, which we thought, again, we had cleaned up, but is now seeing, again, growing contamination from agricultural wastes. And in this case, this algal bloom led to the shutdown of the water supply for the city of Toledo, Ohio, a city of 3 million people, for 3 or 4 days, until the water system was able to figure out how to deal with toxic algae. And in Flint, Michigan, we continue to have challenges providing safe water in a city that we thought we had solved our water problems. And yet, disadvantaged, poorer communities in Flint, Michigan, and in elsewhere around the United States and California, where I live, continue to fail to have safe water and adequate sanitation in a country that has no excuse for failing to provide safe water and sanitation for everyone. We see daily reminders of the fact that we have failed to provide safe water and to provide clean water to everyone around the world. And there's a Kashmiri proverb that says, "It is easy to throw anything into a river, but difficult to take it out again." And that is the water quality challenge we face. Third, food production requires water. Worldwide, 80% of the water that humans use goes to food production. And this issue of food security and water is the same kind of a problem. Many regions of the world are experiencing uncontrolled overuse of groundwater. And by some estimates, as much as a third of the world's food production comes from regions that are using groundwater unsustainably. And that cannot continue. And yet world population is growing. 7 billion, 8 billion, 9 billion people, and we have to continue to grow food for them. Fourth, the conflict between human uses of water and ecosystem uses of water is growing. The reality is, for too long, humans have taken the water out of ecosystems that ecosystems also need, and those ecosystems are suffering. Many of our ecological problems worldwide are water problems and are the result of either taking too much water out of ecosystems or the ecological consequences of taking that water out. The Salton Sea in the United States, the Aral Sea in the former Soviet Union, the Nile Delta, the Everglades, the Yellow River in China. I think all of you can think of a river or a stream that's too polluted or no longer has the water required to sustain ecological health. But another big piece of the ecological problem is, of course, the climate problem. We are changing the climate, and that will have and is already having serious impacts on water resources. The hydrologic cycle that you all learn about when you're young in school is the climate cycle. And there's growing evidence that as we change the climate, we will change precipitation patterns and evaporation and storms, the frequency and intensity of storms and droughts, disappearance of snow and ice, changes in the demand for water. As we change the climate, we will affect water resources worldwide. Even worse, this isn't a new story. It's increasingly apparent that we've waited too long to deal with the issue of climate change, to prevent climate disasters from accelerating. And much of the dramatic weather we've seen, the increased storm frequency, the increased storm severity, increased extent and severity of droughts, are harbingers of things to come. Climate is critical for our water system's supply and demand. And I would note, again, this is not a new story. This is a quote from a study done in the United States almost 20 years ago. And it says, "The evidence is increasingly compelling that humans are changing the water cycle of the United States." Again, 20 years ago, we knew this, and yet we have failed to act on climate issues. Fifth, water and politics makes a volatile combination. Again, this is a focus of the Boris Mintz Institute, conflict resolution. And we do a lot of work on this issue at my institute, at the Pacific Institute. We maintain something called the Water Conflict Chronology. It's an open source database on conflicts over water going back 4,500 years. You can go to the worldwater.org website and look at this database. Each of these dots represents an example where water was used as a weapon or a target of conflict or was a trigger of conflict. And the bad news is that conflicts over water are growing, not shrinking. This is a graph that shows from 1930 up until the present the number of entries, the number of examples of conflicts over water worldwide. More and more of these are not nation-to-nation disputes over water, but subnational disputes over water. And we have strategies for dealing more with international disputes over water and not so much with these subnational disputes. And I'll talk a little bit more about that a little later. I would note one of these examples is around the year 30 AD. Pontius Pilate used money diverted away from the Jewish communities in Jerusalem to divert water away from some rural Jewish communities into occupied Jerusalem. And tens of thousands of Jewish citizens protested this. There was a riot. They were attacked and killed by Roman soldiers in an example of violence associated with challenges over access to water. And yet, in just the last few years, we've seen the same kind of violence over diversions of water away from rural communities in India, in South Africa, in Kenya, in Iran, in Mexico, and elsewhere. We may not see wars over water, but we are seeing and are likely to see increasing violence associated with water resources. Now, our first reaction to these kinds of problems, to challenges with access, to political issues, to environmental challenges associated with water, to difficulties between cities fighting over water for agriculture. Our first traditional reaction is that we just need to spend more money to do the traditional things that we've always done to deal with our water resources, to pay more attention to the problems. That is, to do what we did in the second age of water. And what I'd like to argue is that doing more of the same is not enough. The things that we did, the tools that we learned, the technologies that we applied in the second age of water brought enormous benefits to us. We're all better off because of them. But they also brought some large and unexpected costs. Economic challenges, environmental challenges, particularly social, political challenges. And as I've noted, they haven't solved all of our water problems. It's time to look elsewhere for answers. And I'm going to discuss what I think is the way forward. But before I do, a short digression. I'm a scientist by training. I work at the intersection, as you heard, between science and policy. I believe wholeheartedly in the critical role that scientists play and can play and should play in speaking out to the public, to policymakers, to the media on these global challenges. But like all of this, I come with some built-in biases. The social science community describes something that they call the deficit model, or the information deficit model. And very simply, this is the idea that public skepticism or the lack of action by policymakers or even hostility on the part of policymakers is, despite the evidence that we face very serious challenges, is the result of a lack of understanding, that if only they knew more, if only we could show them more graphs or more facts or more information, that they would do the right thing, that better policy would result. Now, I believe this. I believe in the deficit model. I believe that facts and science and information are critical. And I spend a lot of time when I can talking to the media and talking to policymakers and going to schools and talking to children. I have to say, a digression in a digression, the most difficult talk I ever gave was to a class of second graders. In the United States, they're 7 and 8-year-olds. And I like to think that I'm pretty good at communication, but those second graders, they ate me alive. And it was a good example of the need to understand not just what you're talking about, but your audience. And the deficit model sometimes fails to take that into account. But again, I believe the deficit model, and that was the heart of what Thomas Jefferson believed in the United States in his vision of democracy. And let me share a quote with you from Thomas Jefferson in a letter he wrote in 1820. "I know no safe depository of the ultimate powers of society but the people themselves. And if we think them not enlightened enough to exercise their control with a wholesome discretion," the idea of democracy, "the remedy is not to take it from them, but to inform their discretion by education. This is the true corrective abuse of constitutional power." And I believe that. But there's also strong evidence that simply giving people more information may not be enough to change their views, their beliefs, or their actions. Take the issue of climate change. It's clear from a purely scientific point of view, and I'm a climate scientist by training, that climate change is real, that it's caused by humans, that the impacts will be bad, and that serious global action is required, and that the cost of taking action is far less than the cost of failing to take action. It's also clear in my mind that some of us have been saying that for a long time, and yet we haven't done much. We haven't convinced policymakers to take action. And so critics of the deficit model note that the role of science or data or information in influencing perception and views can be limited, and that changing minds is also based on other factors, like ethical and religious belief, like political ideology, culture, history, personal experience. And unless these factors are taken into account, the simple deficit model isn't enough. And so it's important as we think about solutions to climate problems or water problems or energy problems or food problems, that we think about science and we think about data and we think about information, but we also think about culture and perception and ideology and belief. Now, I suspect this particular audience is a little less difficult to convince of these problems than others, including my second graders, and is more interested in thinking about solutions to these challenges. And so with that in mind, for the last part of my talk, let me talk about solutions. Let me talk about what do we do about this problem? So here's the good news. I think we're living in a transition. I think we're in an important transition from the second age of water to what I'll call the third age of water, an age of sustainable water management and use. I'm an optimist by nature, although some people have told me that an optimist is just a badly informed pessimist. But I'm an optimist by nature. I think there's a lot of good news out there. I think we live in a period of time when there's a tremendous amount of innovation going on, when there's a tremendous amount of progress in science and economics and policy, when talented people are making educated advances every single day. So let me describe pieces of what I call the soft path for water that will help define this third age of water, this age of sustainability. So the first is we have to refocus our efforts and meet basic human needs for water for all humans as a top priority, as a human right, as a moral necessity. Governments, international aid organizations, corporations, private groups at all levels have to join forces to meet this goal, the Sustainable Development Goal for 2030, SDG 6, of providing universal access to safe water and sanitation. The economic costs of meeting basic needs for water are very low, much lower than the costs of failing to provide for those resources, to failing to meet those needs. And there are efforts underway to do this, but those efforts are inadequate. The world community has an opportunity to play here in applying old technology and new technology in new ways. And again, we heard this morning examples of efforts to use relatively simple strategies to meet basic needs for water and sanitation in communities that don't have it. The day when the richer countries and NGOs would go into a community and drill a well and provide a pump and leave are over. The pump would break, the technology was not local, the local community didn't understand how to access the new technology. Those days are ending. And what we see today are new efforts to work with local communities, to figure out what local communities want and need, and to how best provide the information, the money, the technology that might be useful to them in a way where they control their own resources. And I would note that the efforts going on in India right now on open defecation are driven by politics and social dynamics and culture in India and are proving to be an example of, among many examples, of a successful model. Second, we have to meet the basic water needs of ecosystems the same way we have to meet basic human needs for water as well. And we're beginning to explore this as well. This is a picture of a dam in the Pacific Northwest in Washington State in the United States called Elwha Dam. It was built many, many years ago. It provided a little bit of hydropower for a logging industry that was cutting down trees in the Pacific Northwest. And a few years ago, as part of a movement in the United States and elsewhere to remove big damaging ecologically damaging infrastructure like this dam was removed and the Elwha River was restored. A salmon fishery that had been destroyed many, many years ago has been revived, and the river is free-flowing again. And in the United States, about 1,000 dams, mostly small dams, much smaller than the Elwha Dam, dangerous dams, particularly ecologically damaging dams, have been removed. And there are efforts to restore natural ecosystems, natural marshes and wetlands going on around the world. And we see this, again, not just in the United States, but elsewhere. There are guarantees in the South African Constitution for water for natural ecosystems. There are proposals for new standards of environmental management. Israel has taken efforts to restore and protect some of the Hula Valley wetlands that are critical for migratory birds and endangered species. Groups like EcoPeace in Israel and Jordan and Palestine are working on joint efforts across political boundaries to protect and restore ecosystems. We're going to have to deal with the issue of global climate change and its implication for ecosystems and the hydrologic cycle. We've built and operated all of our water systems, assuming that the future climate was going to be the same as the past climate. And we know that's no longer true. And yet, we are beginning to see worldwide strategies for reducing greenhouse gas emissions, including strategies that combine smart energy systems, like renewable energy systems, that require little or no water per kilowatt hour of electricity produced, as a way of eliminating greenhouse gas emissions. And it turns out that strategies for reducing water use also save energy and also reduce greenhouse gas emissions. So there are ways of thinking about energy and water together, or water and food together, that can also address the climate issue. Third, we have to rethink what we mean by water supply and water demand and become more productive in our use of water in our homes, in our communities, and in our farms. There is wasteful, inefficient use of water in every sector of society. So think about it this way. We don't want to use water, except for the most basic things like cleaning and sanitation and drinking and cooking. What we want is food and goods and services and semiconductors and communication. All of the things that we want require water to some degree. But I'd like to argue that all of the things we want require less water than we're spending today to provide those things. We can grow more food with less water. We can make semiconductors and medicine with less water. We can wash our clothes and flush our toilets with less water. Our goal is to provide goods and services. And if we can do those things more efficiently, we can reduce pressure on our water resources. And so in California, we're trying to figure out how to get rid of our grass lawns. The idea of a grass lawn in a hot, arid climate has always been a ridiculous idea. But it's an example that we Americans brought over from Great Britain to the east coast of the United States, where water is more abundant. And then we brought that idea with us to the western United States, where water is not abundant, where we live in an arid, water-scarce region. And so in the western United States, in our cities, more than half the water that we use goes to outdoor landscaping, which is ridiculous when you think about it. And so we're now exploring ideas of having beautiful gardens, but not lawns, not water-consumptive gardens. Our toilets are much more efficient than they used to be. Our washing machines and appliances are more efficient than they used to be. We're able to do more and more with less and less water. And the same, of course, is true for agriculture. We can grow more food with less water by moving from flood irrigation to sprinklers, or moving from sprinklers to precision drip, as has been innovated here in Israel. And this is already happening. We're improving the efficiency of our water use. And let me show you one of my favorite slides for the United States. This is a graph that shows from 1900 up until the present the gross national product of the United States, and a measure of economic well-being. It's this red curve going up and up and up, and it's what economists love to see, that is exponential growth in our economy. And I'm not going to get into the question about whether that's a good idea in the long run or not, but economists like to see it. And the blue line is total water withdrawals in the United States for everything, for agriculture, for power plant cooling, for flushing our toilets and washing our clothes and watering our lawns and making semiconductors. And it shows two things. It shows, first of all, the idea that most of us are taught in school that as our economy grows, our demand for water also grows. Our economy and our population, I would note. The population curve is the same exponential growth curve. But it shows something else as well. It shows that those two curves don't have to grow together. And in the late 1970s and the early 1980s in the United States, those two curves split apart. And in the United States today, we use less water for everything than we did 40 years ago, and much less water per capita than we did 40 years ago, despite a growing population, despite a growing economy. Cutting back on our water use didn't cripple our economy. And what this is a change in economic growth, a change in economic use of water. It's an improvement in the efficiency of water use. It's a change in diet. There's a lot going on in this curve. But the reality is we do not have to assume that a growing population and a growing economy requires that we take more and more water out of our ecosystems. And I would note also, if this curve had continued to grow exponentially, we would have had to more than double the total amount of water used in the United States. And I don't know where that water would have come from. We already overpump our groundwater. We already dry up the entire Colorado River in the western United States. We're already at our limits in the United States and in many parts of the world in our use of water out of our natural systems. But this is good news. This shows that we can meet our needs with less water. But the other side of the equation is not the demand side, but it's the supply side of the equation. And here there's also good news. There are smart, new, innovative things that we can do on the demand side of the equation as well, especially where there's no new water to be found, where there is no more groundwater to be used, where we're using the entire flow of our rivers, like the Jordan or the Nile or the Yellow River or the Colorado River. I would note that there are places around the world where we do need to pour more concrete, where we need to build more traditional infrastructure, where new investments need to be made in existing water systems. But we have to think differently about supply. So rather than taking more water from overtapped aquifers, from overtapped rivers, we have to look at the smart conjunctive use of surface water and groundwater together. We have to think about how to recharge groundwater aquifers. We have to relearn traditional methods of rainwater harvesting and stormwater capture. We have to realize that treated wastewater is an asset and not a liability. And again, I would note, Israel has been a pioneer in this. We have to learn how to deploy desalination where it's appropriate, environmentally and economically. And again, the good news is that we're doing this. The top left is a groundwater replenishment system in California that for 30 years has been taking highly treated wastewater and using it to recharge overtapped groundwater aquifers, groundwater that's then reused for agriculture and human uses. Urban stormwater capture, where instead of figuring out how to take stormwater and get rid of it as quickly as possible, we're learning how to recharge groundwater in urban areas and to restore urban rivers and urban streams. And of course, desalination to turn some of that 97% of the world's salt water into high-valued urban and industrial uses of water. Fourth, we have to better protect water quality. A top priority has to be the protection of our tap water. Most of our tap water in industrialized nations is incredibly high quality, often as good or better than bottled water. And yet, somehow the bottled water industry has convinced us that their water is better than tap water. Sometimes it requires updating and improving our urban water systems. And again, Flint, Michigan is an example in the United States of a city that had great urban water, but failed to invest adequately in protecting that water. Fifth, we have to use smart economics. The failure to price water properly leads to overuse, to underinvestment, to poor economic decisions. Most of us don't pay enough for the water services that we get. But water also has to be fairly priced to reflect both its cost, to encourage efficient use, but also to protect poorer populations. There is a legal human right to water. The UN declared a human right to water in 2010. And so that means eliminating some subsidies for water, redesigning other subsidies, developing appropriate water markets. So let's recognize both the human right to water and its economic value. Those don't necessarily conflict. Finally, we have to improve our water institutions. Nelson Mandela said in the year 2000, interestingly enough, in the context of water resources, it is one thing to find fault with an existing system. It is another thing altogether, a more difficult task, to replace it with another approach that is better, referring to our water management. We have 19th and 20th century water institutions. We need 21st century water institutions. We need water utilities that work with energy utilities to improve access to both water and energy. We need decentralized water institutions in rural areas, as we need sometimes decentralized water infrastructure as well. We need not just engineers and traditional water managers, but people who understand economics, people who understand culture and social dynamics, who understand policy, who are truly interdisciplinary. And that's going to require that our universities teach interdisciplinary water management, something that Tel Aviv University is doing, that other universities are doing, but that is still not being done enough around the world. So in conclusion, yes, we have a water crisis. Yes, some things are getting worse and not better. But I also believe we're in this transition to a more sustainable future. We're moving from the second age of water to the third age of water, to a true, what I hope will be, a true era of sustainability. I think that the success stories that we see out there are examples of the way forward. I think we're seeing new collaborative efforts between farmers, between environmentalists, between industry and the energy sector and water agencies. It's possible to change our governments in a way that maintains the regulations that we put in place, but develops new strategies for dealing with water in an integrated fashion. I think the shifts to a third age of water are underway. And in my work and in the work of many others, including some of you, I hope we can find ways to continue it and to make it happen faster. Thank you again for the great honor of being the 2019 BMI laureate.